Okay, now we're going to take a graph of either a sine or cosine function and find the equation of that graph. But this time we have one that has been shifted. Okay, so first we have to decide, is this a sine or a cosine graph? Well, you could call it either one. You could call it a cosine graph if you considered this the starting point and this the ending point. Then it looks like a cosine graph. But it's always easier if we don't have a phase shift. So if we consider this the starting point and this the ending point, then there's one complete cycle of a sine graph where this would be the midline, right? So up, down, and back up to the center point. So let's call this a sine graph because that way it doesn't have a phase shift. If we called it a cosine graph, it's shifted to the right before it starts that starting point. The starting point's not at 0. So we'll call this a sine graph, and our starting point is at 0. At one complete cycle is completed at pi. So we'll go from 0 to pi, it has one period of sine. Okay, so our general equation for sine is y equals k plus a sine of bx plus c. Step 2 is finding the center line, which also can be called the midline. Okay, so that's taking the middle of the graph, or another way of finding that is taking the high point plus the low point and then divide by 2. The maximum value is at 5. The minimum value is at a -1. 5 plus -1 is 5 minus 1, which is 4. Divided by 2 is 2. And that matches up with what we can see here. It goes through at y equals 2. Okay, so whatever that center line is, I wrote here x equals 2. That should have been a y equals 2. That y equals 2 is our k value. Whatever the center line is, that's our k value. So k is equal to 2. Okay, next we need to find the amplitude. The amplitude is the distance from the center line to the top of the graph. Another way to find the amplitude is taking the max value minus the min value and divide by 2. 5 minus a -1 is the same thing as 5 plus 1, which is 6, divided by 2 is 3. And that matches up with our amplitude of 3. The distance from the midline to the top is 3. Going from 2 to 5 is 3. Okay, so that's our amplitude is 3, which means A equals 3. Now, step 4 is finding the period. Okay, the period is the ending point minus the starting point, right? It starts at 0. It goes through one period by the time it gets to pi. The starting point is 0. The ending point is pi. So ending point minus starting point equals pi minus 0, which equals pi. Okay, now by definition, the period is equal to 2 pi over b. So the pi that we get from looking at the graph, knowing that it goes through one cycle and it takes pi to go through one cycle, we know the period is pi. And by definition, period is equal to 2 pi over b. So we have 2 pi over b equals pi, then cross multiply. B times pi is b pi equals 2 pi times 1 equals 2 pi. So if we have b pi equals 2 pi, divide both sides by pi, then we get b equals 2. So now we've got k, a, and b. Now we need c. Okay, so we find c by finding the phase shift. Again, the phase shift is whatever the starting point is. Our starting point here is at 0. right? It starts at 0. The phase shift is the starting point, which is 0. And then by definition, the phase shift is negative c over b. Now we replace this b with 2 because we found that in the previous step. We found that b was 2 in the previous step. So negative c over b is the same thing as negative c over 2. So since the phase shift is the starting point, which equals 0, and the phase shift is equal to negative c over 2, we set those two equal to each other. Negative c over 2 equals 0. Now cross multiply. Negative c times 1 is negative c. 2 times 0 is 0. If negative c equals 0, then c has to equal 0. So now that we've got all the values k, a, b, and c, then we plug them all into the general form for a sine graph. So you'll end up with y equals 2, that should be a 2, plus 3 sine of 2x plus 0. And then you don't use that 0, then it ends up being y equals 2 plus 3 sine of 2x.